Hi viewers, welcome to my class on mechanics of materials. In today's class, the topic which I am going to discuss is generalized Hooke's law. All of you have studied Hooke's law. Hooke's law states that normal stress is directly proportional to normal strain within the proportional limit or elastic limit. When a body is subjected to three-dimensional state of stress, generalized Hooke's law can be used to find out the resultant strains in x, y and z directions. So for this we can use the theorem of superposition. So from the Hooke's law, which you have studied, when stress is acting in a direction, you can find out the strain induced in that direction as stress by Young's modulus. So you are getting the direct strain, and you can also find out the lateral strains induced in the other directions. So separately you can consider the loads. When the loads are acting in three directions, individual loads you can consider, and you can find out the strains induced in x, y, z directions due to each load, and then finally you can find out the resultant strain induced in these directions. Now let us consider a block subjected to stresses in x, y and z directions. So it is subjected to three-dimensional state of stress. In x direction, stress is acting. Stress means load is acting in x direction. So as a result of load, there is a stress in that direction. Load divided by area of that cross section. So that will give the stress in that direction. Similarly, it's also loaded in the y direction. So y direction, when load acts, stress in y direction is load divided by that area normal to the y axis. So this area, and also load in z direction. So you can find out the stress in z direction as load in the z direction divided by this area. So stresses are acting in x, y, z directions. You need to find out the resultant strains induced in x, y and z directions. The generalized Hooke's law gives the strain induced in x, y, z direction. Now let us remove all the loads and only place the load in x direction. So stress is acting only in x direction. So I removed the load which are acting in y direction and z direction. So only load is acting in x direction. So resultant stress is sigma x. So sigma x is a stress in x direction. So due to this load, the strain induced in x direction is sigma x by e. Okay, in this x direction there is a direct strain sigma x by e, but this also causes strain in y direction and also z direction, and that is lateral strains. And lateral strains, if you take the sign into consideration, lateral strains are always of opposite sign. So you can take the lateral strain as linear strain multiplied by Poisson's ratio, but of negative sign, because lateral strain is always of opposite sign. So strain induced in y direction is going to be minus nu times sigma x by e. Sigma x by e is a direct strain in the direction of the load, but in the lateral directions it will be less, and it will be strain in x direction multiplied by Poisson's ratio, but of opposite sign, because when you take the sign convention you have to show minus. If this is tensile strain, lateral dimension, you will have a compressive strain. If it's a compressive strain in x direction, that will induce a tensile strain or a positive strain in y and z directions. So in x direction it is here it is a tensile load, so you will have a positive strain in x direction but negative strain in y and z direction. So z direction is also minus nu times sigma x by e. So these are the strains induced in x, y, z directions as a result of loading in x direction. Now we will remove all the loads and only place the load in y direction. So individually you are placing one load at a time. So in y direction I will place the load and remove all the load in x and z direction. Now strain in y direction is going to be direct strain caused by this load, and you get the strain in that direction. Y direction is sigma y by E. So in y direction you will have sigma y by E. That is a direct strain, because the load is acting in that direction, that will induce a strain sigma y by E. This is directly from Hooke's law. Now but x direction and z direction, it will induce a lateral strain. So that is going to be this direct strain multiplied by Poisson's ratio, but minus I have used to get the sign convention. So other x direction and z direction, you have this multiplied by minus nu. Okay, so strain in x direction is minus nu times sigma y by E. Strain in y direction is sigma y by E. Strain in z direction is minus nu sigma y by E. Now let us place the load only in z direction. This z direction load will induce a strain in z direction. That is a direct strain. Because of this load, directly it is inducing a strain in z direction, that you can find out by sigma z by E. It's a direct strain caused by that load in that direction. But the other two directions also induce a strain. This load is inducing a strain in x direction and y direction, but it is lateral strain and they are of opposite sign, and it is less, nu times less. Okay, so you have to multiply this by nu, and with a sign convention minus you can use. So it is Ez, z direction you have direct strain sigma z by E, x and y direction we have minus nu sigma z by E. Okay, even though there is no load in x direction or y direction, it is inducing strains in x and y direction due to the load acting in the z direction. So you have obtained the strains induced in x, y, z directions when the loads are acting separately. Individually, x direction when load acts, what is the strain induced in x, y, z direction? When y direction load acts, you got the strain induced in x, y, z direction. And z direction when load acts, the strain in x, y, z direction. Now if all the loads simultaneously acts, okay, individual load you got the strain in x, y, z direction, but if all of them simultaneously acts, what is the strain induced in x, y, z directions? So that you can use theorem of superposition. Consider all the forces simultaneously acts on the block. So the stress is acting in x direction, y direction, and also in z direction. Now to find out the resultant strain induced in x direction, y direction, and z direction, we have already considered in separate x, y, z directions. When x direction stress acts, these are the strains induced in x, y, and z direction. When it acts in the y direction, strain in x, y, z directions we have calculated, and when it also act only in z direction, we have the strain in x, y, z directions. This is individually when the forces acts, the strains induced. These are the strains induced when the forces acts only in one direction. Okay. Now when all the forces are simultaneously acts like this, you have how to find out the resultant strain induced in x, y, and z directions. So individually we have calculated the strains induced in x direction when each force is acting. So when all acts together, you can find out the strain in x direction as the summation of strain in x direction caused by individual forces. This force is causing a strain in x direction. Ex is equal to sigma x by E, and this y direction force is causing a strain of Ex is equal to minus nu sigma y by E, and z direction force is inducing a strain minus nu sigma z by E. So when all of them act together, the strain is addition of all the three. Strain in x direction, individually what we have got, just add all the three, which will give the strain in x direction. So adding these three, sigma x by E and minus nu sigma y by E minus nu sigma z by E. So add all these three terms, which will give the resultant strain in x direction. Similarly, to find out the strain in y direction, when all the three forces act, we have individual strain. When each force acts, we know the strain. So these are the strains in the y direction when individually the forces acts on the block. So when all of them acts together, you should add all the three. So you get sigma y by E. I am using this term first, sigma y by E minus nu sigma z by E, minus nu sigma z by E, and then minus nu sigma x by E. Okay, these three terms, adding these three terms, but I put this first, second and third. Okay, so that you get direct strain first. So Ey is sigma y by E. Okay, that is a direct strain, whereas these terms involves Poisson's ratio, so that they are lateral strains. And next, in z direction, you have, when individually forces acts, these are the strains. So you add all the three, which will give the strain induced in z direction. So you have sigma z by E minus nu sigma y by E and minus nu sigma x by E. So these equations are known as a generalized Hooke's law. When the forces acts in all the three directions, the resultant strain induced in x, y and z directions can be obtained using these expressions. So if stress acts only in x direction, these terms will be 0. There is no stress in y direction or z direction. This and these two terms are 0, and z direction and y direction no stress. So you will get only these terms. Strain in x direction is sigma x by E. Strain in y direction is minus nu sigma x by E. Strain in z direction is minus nu sigma x by E. So if stresses acts only in x and y direction, sigma z will be 0. So this term will be 0. In the second equation, this term 0, and again third equation, this term will be 0. So it all expressions reduced to two terms. So you can find out the strain induced when forces acts in all the three directions using generalized Hooke's law. So first part of all these three equations is direct strain caused by that load in that particular direction. If it is Ex, sigma x by E, direct strain. If it's Ey, sigma y by E. If it's Ez, sigma z, subscript is same. So it is a direct strain, no Poisson's ratio. But loads in the other directions are causing a lateral strain. So in next two terms you have a Poisson's ratio coming with the minus terms. Then y direction load is causing a lateral strain in x direction, that part, and z direction load is also causing a lateral strain in x direction. So after this direct strain, you need to get y and z. X is already direct in the x direction only you are finding out the strain, so it's a direct strain, and y and z should come. This is Ey, direct strain, and then y, after y you can z and x you can put. So here z is the direction, so it is a direct strain. Z, after z you can put x and y. So these equations are known as generalized Hooke's law. So it gives strain in x, y, z directions when loads are acting in all the three directions. When three-dimensional load acts, strains induced in x, y, z directions are given by generalized Hooke's law. Now let us work out a numerical example. So there is a load acting in x direction, 100 kilonewton load, and 40 kilonewton in y direction, and 60 kilonewton in z direction. So the question is to find the change in dimensions of the block subjected to loads as shown in figure. So three loads are acting x, y and z direction. We need to find out the change in dimensions of the block. The stress induced in this direction you can find out as load divided by area of cross section resisting that load. So that is this blue area, load divided by area. This blue area, this dimension is of the block is 200 by 120 by 100. So x direction you have 200, y direction you have 120, z direction you have 100 mm. So this area of this blue face area is 120 into 100. So 100 kilonewton or 100 into 10 raised to 3 divided by 120 into 100 will give the stress in x direction. So let us go for the next. So the loads are tabulated. So it's into kilonewton converted into Newton. The stress in x direction is load divided by area. Load is 100 kilonewton or 100 into 10 raised to 3 divided by area resisting that load is 120 into 100. So this blue phase. So that will give the stress as 8.333 megapascal. Sigma y direction, the load is 40 into 10 raised to 3, and this orange phase, that is 200. This is 200 into 100, that is the area. So that gives the stress as 2 megapascal. In z direction load is 60 kilonewton or 60 into 10 raised to 3. The area resisting is this green phase, so that is 200 into 120. So that will give the stress 2.5 megapascal. So all the three directions you have tensile stresses, so positive values of stresses. Now you can apply the generalized Hooke's laws to find out the strain in x direction, y direction and z direction. So x direction is sigma x by E minus nu sigma y by E minus nu sigma z by E, or 1 by E into 1 by E is taken outside, 1 by E into sigma x minus nu sigma y minus nu sigma z. E is Young's modulus 180 gigapascal, 180 into 10 raised to 3. Sigma x is 8.33, sigma y is 2, sigma z is 2.5. So I substituted the values, you get the strain in x direction as 4.003 into 10 raised to minus 5. Once you get the strain in x direction, you can find out the strain is nothing but the deformations per unit length. So to find out the total change in length in that direction, you need to multiply with the distance in that direction. It is 200. That is x dimension of the block, 200. So you can multiply this with the 200 x dimension. So Ex into x will give the change in dimension in x direction. So this into 200 will give 0.008 mm. Strain has no unit. This is a deformation in unit length. But in 200 mm length, that is the total x direction, so much is the change, 0.008 mm increase in length x direction. Now in strain in y direction is Ey is sigma y by E direct strain minus nu sigma z by E minus nu sigma x by E. And these are the lateral strains. So 1 by E into sigma y minus nu sigma z minus nu sigma x by taking E outside. So 1 by 180 into 10 raised to 3 into sigma y is 2, sigma z is 2.5, sigma x is 8.33. Substituting that, you will get minus 3.93 into 10 raised to minus 6. Minus indicates there is a reduction in length in y direction. Totally there is a reduction in. As a result of forces in three directions, the resultant strain induced is negative. Once you get the strain in y direction, you multiply the distance in y direction, that is 120 mm. This into 120 give minus 0.00472 mm. So this is a reduction in length, because minus you are getting, that means so much is the reduction in length in y direction. Next, strain in z direction, you can use the formula Ez is equal to sigma z by E minus nu sigma x by E minus nu sigma y by E. That is 1 by E into sigma z minus nu sigma x minus nu sigma y. So 1 by 180 into 10 raised to 3 to 2.5 minus 0.25 into stress in x direction 8.33, stress in y direction 2. So you get minus 4.58 into 10 raised to minus 7. So that is a strain induced in z direction. Minus indicates once again it is a compressive strain, the length is decreasing. So this is a decreasing length per unit length. So there is no unit. You multiply the distance in z direction or dimension of the block in z direction, which is 100. So you can multiply this with the 100, which will give the change in dimension in the z direction, which is minus 0.000458 mm. So this is a reduction in length. Minus indicates reduction in length in the block in the z direction. So you got the changes in dimension of the block in x, y, z direction. That's all for today. Thank you for watching.